Welcome to my video on trigonometry, degrees, and radians. In this video, I'm going to talk about a radian, what it is, and just how do you work with that unit of measure for angles. So 1 radian is the measure of the central angle, we're going to call that theta, of a circle that intercepts an arc length equal to the radius of the circle. So that's our definition. Now I'm going to draw a picture that kind of helps illustrate that. So here's our circle, radius r. Now we go another radius r, and then we make this length right here r, and that angle theta, by definition, is going to be 1 radian. So there's our basic definition of what a radian is. Now let's work with it a little bit to get more familiar with it. Circumference is 2 pi times the radius. Let's do another circle here and look at a more general case. This is the case where r, the first case, r and r were the radiuses, and this distance was r. Now let's make that a general distance. We're going to call it this arc length s. So we know that s is equal to r times theta. The arc length is proportional to the radius and the measure in radians. Solving for theta, we get s over r, just rearranging that equation. So now if we take the case where s is equal to r, which was just our basic definition over here, then we get theta is equal to 1 over 1 is equal to 1. So that is just the basic definition here. This is when 1 radian. So we just showed that our equation there satisfies that special case. Now let's look for the case of a full circle. So in this case, this arc length is just the circumference. That's 2 pi times r. Now we know from the top equation that's equal to r theta. Now our r's go away because they both drop out. So theta is equal to 2 pi. And that's the case for a full circle. That's 360 degrees. So that's the case for a full circle. It's 2 pi radians or 360 degrees. So what we just saw was 2 pi radians equal to 360 degrees. Now if we divide both sides by 2, we get pi radians is equal to 180 degrees. Now if we divide both sides by pi, we're going to get 1 radian is equal to 180 divided by pi. That's 180 divided by 3.14, and then on and on. That's approximately 57.3 degrees. So this is the relationship 1. If we convert 1 radian into degrees, is 57.3. So now let's do another circle and look at that some special angles. I'm going to draw my circle on the coordinate plane here. There's our center. Now first let's look at 30 degrees. That's about a 30-degree angle right there. Okay. Now theta here is equal to 0, 90 degrees, 180 degrees, and then 270 degrees. So that's our basic coordinate system. But now let's look at 30 degrees and try to figure out what the radian measure would be equivalent of. One thing we do know is that 30 degrees is 1/3 of 90. 3 times 30 is 90. So we've got 3 there, 4, 5, 6. Those are 30-degree segments, 7, 8, 9, 10, 11, 12. So what we know is that 30 degrees is 2 pi radians, that's for a full circle, divided by 12, which is just equal to pi over 6 radians. Write that a little better, pi over 6 radians. So that's for 30 degrees. Now look at 45 degrees. So there's our 45. Now in this case, we know that 45 is half of 90. So there's 2 segments in the first quadrant, 2 in the second, 2 in the third, and 2 in the fourth. So That's going to be divided by 8. So 2 pi radians divided by 8 for 45 degrees, that's pi over 4 radians. So what this tells us, a 45-degree angle is equivalent to pi over 4 radians. Now let's look at 90 degrees. So at 90 degrees here, that is a quarter of a circle, so that's 2 pi radians divided by 4 pi over 2. So 90 degrees is pi over 2 radians. Going down to 180 here, that's going to be 2 pi, now that's dividing it in half, so that's pi radians is equal to 180 degrees. Down here we have got 3/4 of a circle times 2 pi. We're just looking at the fraction of what 270 is of 360. It's 3/4. So that is going to be 6 pi divided by 4, and that's going to be 3 pi over 2 radians is equal to 270. So our 270 degrees is the same as 3 pi over 2 radians. Those are some special angles. There's others too, just anything that's a 30 or 45 degree multiple. Now let's look at an example. Let's find the radian measure for 1/3 of a full rotation. So for a full circle. Here's our circle. Now 1/3, we know we have 360 degrees is equal to full circle. Divide that by 3, that's 120 degrees. So that's going to be about right there. We draw that angle, that angle theta is 120 degrees. So what we're trying to figure out is, we'll figure out what is a radian measure of this distance right there. What is theta is what we're looking for, basically. So we know one rotation is equal to 2 pi radians. And we know S, that distance, is equal to 1/3 times 2 pi times r, because that's the circumference. So that's the equivalent of c. 2 pi r is c, the circumference. So we've got 1/3. S goes 1/3 of the way around. So S is equal to 2 pi r divided by 3. Now we also know that's equal to r theta. So now the r's can cancel out. So we can get rid of them. So now we know 2/3 is equal to theta. And so that's going to be our units of measurements, because basically r canceled out, so that left us with theta. So in the case of a 120 degrees, our radian measure is 2 pi divided by 3, so that's 120 degrees. Well, I hope you learn a little bit about radian measure, and about this is a good foundation of trigonometry, and thank you for watching.